Okay, class, picking up where we left off at, we have 6x to the third over 5 divided by 4x to the fifth over 7. So we wrote 6x to the third over 5. Division becomes multiplication, and we take the reciprocal of this fraction. So now, we have 6 times 7, which is 42. 6 times 7 is 42, and we have our x cubed, all over 5 times 4, which is 20, and we add x to the fifth. Now, 42 and 20, we know both of these numbers have 2 in common. So we could divide both of these numbers by 2, and then that would give us 21 over 10. Now, we still will have our x to the third and x to the fifth. Now we could go off to the side here, and we know we have the same base, so we subtract the exponents. So we will have x to the 3 minus 5, which would be x to the negative 2. And we know x to the negative 2 is 1 over x squared. So that means that our answer here, the x squared, will go in the denominator. So our final answer here will be 21 all over 10x squared. And that is it. Now we get down here to b. Now we can factor out a 2, and we will add x plus y, and that's all over 8z, times. We know we would take the reciprocal of this here, so 72 would be in our numerator, and then in our denominator we will have x squared times x plus y, and I want to write this twice, times x plus y, because x plus y was parentheses squared. So this x plus y and this x plus y simplifies. Now, we know 2 goes into 2 once, 2 goes into 8 4 times, 4 goes into 4 once, and 4 goes into 72 18 times. Now for our numerator, we would just be left with 18. In our denominator, we would be left with x squared, z, and then x plus y. And that's it. Now we scroll down. Now we come to C and D. Now class, we need to factor these fractions here. Now again, I would tell you, if you need help with factoring, you could always go back to chapter 6 to get your factoring. But when we factor this out, this becomes z minus 4 times 2z plus 3. In our denominator, we will have z minus 12, and we will also have z plus 2 times. Now we know we would take the reciprocal of this fraction here, so our numerator would be z minus 3 and z minus 6. Our denominator would be 2z minus 3 and 2z plus 3. Now again, since we're taking a reciprocal, we know this is the difference of 2 squares, which would be in our denominator, and then this is a regular polynomial that we would factor. Now we simplify out. Now we have, we have 2z plus 3. If we could simplify out here, we have, it doesn't look like we have anything else in common. So our final answer would be z minus 4, z minus 3, z minus 6, all over z minus 12, z plus 2, and 2z minus 3. So this is our final answer here. Now we come here to D. Now, okay class, I took the liberty of factoring these polynomials here. We have 2x for our numerator. Our denominator, you know, based upon chapter 6, we will use the grouping method, and that will leave us 3a plus 4 and x minus 2. Now, you know we would take the reciprocal of this second fraction, and after we factor this here, it will give us a minus 3 and 3a plus 4. And in our denominator, the only thing we have in common between these two terms is 2x squared. So that will leave us a minus 3. Now we simplify. We can simplify the a minus 3's, the 3a plus 4's. And now these 2's will simplify. And we know this x goes into x once, and then x goes into x squared x times. So now, in our numerator, since everything's simplified out, it'll be 1. In our denominator, we will have x and then x minus 2. And that's it. Now, just as a reminder again, if you need help with factoring, go back to the Chapter 6 videos to help you with factoring. Okay, now, we scroll down. Now we come to example 5. We need to factor this first equation here, which will give us b plus 6 and also b plus 6. And that's all over b minus 4. And this division will become multiplication. And your numerator here will be 1. Your denominator would be b plus 6 and b minus 3. That's after you factor these values. So the b plus 6's will simplify out. And in your numerator, you would just be left with b plus 6 all over b minus 4 times b minus 3. And that is your final answer. Now we go here to b. We have x squared over y divided by x over y squared. We should always change the problem if we can, because all this is this here. So we would have x squared over y times, we'll take the reciprocal to be y squared over x. Now, this is how we would do it. We can do cross simplifying. X goes into x once, x goes into x squared x times, y goes into y once, and y goes into y squared y times. So in our numerator, we will have xy, and our denominator, we will have 1. Xy over 1 is just xy. Now we come here to c. It's the same setup. We'll rewrite this. So we set this problem up like we did the other problems. So we would take 3 over 5x plus 5 divided by, we would have x cubed all over x squared minus 3x minus 4. Now, we would keep this first fraction the same, but we can factor out a 5 in our denominator, and that will leave x plus 1. Division will become multiplication, and you know we would take the reciprocal of the second fraction, and this factors out to be x minus 4 and x plus 1. And then our denominator will be x cubed. Now, we can simplify out these x plus 1's, and we can say x goes into x once, x goes into x cubed, x squared times. So now we would be left with 3 times x minus 4 all over 5x squared. And that is it. Now we move on to section 7.3 and 7.4, adding and subtracting rational expressions. We call 5/12 minus 3/12. Now, remember, in order to add or subtract fractions, we must have the same denominator or a common denominator, and we carry over the denominator and we add or subtract the numerator. And since this is subtraction, we will subtract. So we'll take 5 minus 3, which is 2 over 12, and we'll divide out what they have in common, which is 2. So it'll be 1/6. Now, we come down here, adding or subtracting rational expressions with a common denominator. We know a over b plus c over b is a plus c all over b. And a over b minus c over b is a minus c all over b. That is to add or subtract rational expressions with the same denominator. add or subtract the numerators and keep the same denominator. Now, we even do this when we deal with algebraic expressions. We know our denominator is going to remain x. Now for our numerator, we'll put 5x plus 2 plus 4. And we will combine any like terms. So that will leave us 5x plus 6 over x. And there's nothing we can simplify, so we're done with that problem. Now we come here to b. Our denominator is x minus 3. In our numerator, we have 9x minus 5x, which is 4x over x minus 3. Now for c. Now we look here, same denominator. So we know our denominator would be c squared minus 16. Our numerator, what we could do is we could combine the like terms as we go. We know it's only a c squared here, but we have a negative 5c plus 3c, which would give us a minus 2c, and then plus a negative 24 would give us minus 24. So now, let's factor this. Our denominator would be c minus 4 and c plus 4. Our numerator would be, we would have c minus 12. No, we would have, for 24, we would have c minus 6 and c plus 4. Now, these c plus 4s will simplify out, and our final answer would be c minus 6 all over c minus 4. You don't have to put the parentheses there, but this is the final answer. Now we come here to d. Same denominator. We keep the x plus 7. Our numerator, we're subtracting. So first of all, x squared will remain x squared. Anything behind this minus sign in your numerator, it will change its sign. This will be a negative 4x. This will be a positive a negative 14. So this is really 9x minus 4x, which we know is a positive 5x. And then this will end up being, since this is a positive 14, it'll become a minus 14. Now, we can factor in our numerator. This factors out to x plus 7 and x minus 2. In our denominator, we have x plus 7. These x plus 7 simplify out, and you have x minus 2 over 1, which we know when we divide that out, that would just give us x minus 2. Now it says warning. When subtracting rational expressions, be sure to subtract the entire numerator. So what they're talking about is these values behind the subtraction sign. So you would take the opposite of both of these signs, which we did. Now we come to the next group of problems. But as you notice here, with fractions, we always deal with problems that do not have the same denominator. So we have to find the least common denominator. Number one, we will factor each denominator completely. Then we will list the factors of the first denominator. Add to the list in step 2 any factors of the second denominator that do not appear in the list. Form the product of the factors from the list in step 3. This product is the least common denominator. Compare this situation with finding the least common denominator for 3 over 40 plus 7 over 50. So now what we would do with this here, we want to find the least common denominator of 40 and 50. Now, what I typically teach from Math 020, and a lot of you have experienced this, is the prime factorization method. So what we would do is we would find the prime factors of 40 and 50. So I would go off to the side here. I would take 40 and I would take 50. 40 breaks down to 2 times 20. 2 is prime, 20 is not. 20 breaks down to 2 times 10. 10 breaks down to 2 times 5. So 40 breaks down to 3 2s and a 5. Now 50 breaks down to 2 times 25. 2 is prime, 25 is not. And 5 breaks down to 5 times 5. So we have 2 times 5 times 5. Now to build our LCD, what we would do is this here. We'll look at what they have in common as far as the digits. Both of these values have 2 in it, but the one that has the most 2s, that's what you list down here in your LCD. So that takes care of all of the 2's. And we do the same thing for the 5.